Okay, so in this video we're going to talk about horizontal shifts, right? So we looked at vertical shifts. Now what are horizontal shifts? So again, let's consider three functions, right? I'm going to have my base function here as fx equals x squared. Then I'm going to look at gx, which is x minus 2 squared. Remember, it is not x squared minus 2, it's x minus 2 squared. And then hx is x plus 3 squared. Okay, so let's go ahead and make our table again. So I have x, I'm going to take points. I have -3, -2, -1, 0, 1, 2, and 3. I have x squared, which is going to be 9, 4, 1, 0, 1, 4, and 9. Then I have x minus 2 squared, right? So here I would have -3 minus 2 squared, which is going to be 25. I have -2 minus 2, which is -4 squared, which is 16. 9, 4, 1, 0, 1. And finally, we have x plus 3 squared. So if you look here, if I put in x equal to -3, I get -3 plus 3 is 0. So 0 squared is 0. -2 plus 3 is 1, and 1 squared is 1. This is going to be 4. I have 9 here, 16, 25, and 36. Okay, so what do we notice again? Well, let's go back to our graph. So here are my points, the table that I created. I put it in here, and then here are the points for our base function, that is x squared, and you can see here again that that sort of follows a parabolic pattern. So I'm going to go and click on y equals x squared, and of course our points fall on the function or on the graph of y equals x squared. So now let's take a look at our second function, which was x minus 2 squared, right? So this doesn't look like a parabola at the moment because I only have a few points, but let's go ahead and see if I plot this graph, what does it look like? Well, here you go. So we look at y equals x minus 2 squared, and we see that this graph has actually, all the points have moved by 2 units to the right, right? So the point at 0, 0 moved to 0, 2. The point at 1, 1 moved to the point at 3, 3. The point at -2, 4 has moved to 0, 4. So the entire graph is actually shifted by 2 units to the right. Okay, now let's go ahead and look at the third set of points here, and the third set of points here we have are in black over here. So let's go ahead and get our function. So if I get our function, we now see that this graph x squared has moved by 3 units to the left, right? So x plus 3 squared has now moved 3 units to the left. So the point 0, 0 is now at 0, -3. The point at 1, 1 is now at -2, 1, so on and so forth. Okay, so then again the question is, what would happen in general if I added an h to the x, right? So if I had the function x plus 8 squared, what would happen? So if h was 0, well, x plus 8 squared is nothing but x squared, and so obviously we get this function x squared. Let's see what happens when we make h positive. So I'm going to go ahead and make h positive, and I see that as I make h positive, it's moving to the left, right? Remember, it's not moving to the right, it's moving to the left, right? So as h gets bigger and bigger, it moves away from your origin, right? Now, well, what happens now when h is negative, right? So here's h is 0. So as I make it negative, well, now it starts moving away from the origin in the positive direction, right? It's moving to the right. So as h is negative, the function is moving to the right, and as h is positive, the function is moving to the left. Okay, so then how do we detect a horizontal shift, right? So let's h be greater than 0, or let h be some positive number. Then the graph of gx equals x minus h squared is the graph of fx shifted horizontally or shifted to the left. shifted to the right by h units, and the graph of hx equals, actually let's use a different one here so we don't get confused, and the graph of kx equals x plus h squared is the graph of fx shifted left by h units.